better, they're long. But then when they're like 3 different short videos, they're like, oh, that one, click the link.
The issue for me is uploading them to YouTube. If they're too long, it gives me a problem sometimes for uploading. So, all right, here we go. So find the derivative. Now here's the deal. In about 3 or 4 days, you guys are going to be able to do that, and that's your answer. All right, you're going to be able to find the derivative like that.
Wait,
but you don't know how to do that yet. Nope, stop. You don't know how to do that
That's
yet.
the answer?
That's the answer. But you don't know how to do that yet.
have the
So you're
answer.
going to figure that out later. Some of you are like trying to figure out how I did that. That's good. It's a secret. Stop. Okay. So this is the short way, okay? You'll be able to do that later. Right now, though, we have to use definition of derivative to show what the derivative is. So here we go. It's going to be the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Notice I've gone back to x's instead of c's. Usually we use the c when we have a definitive point that we're going to plug in. And we use the x when we're just kind of talking about it in general. Okay. All right, so we can do this. The limit as delta x approaches 0, f of x plus delta x, I'm going to take that and plug it in for my x's here. So I'll have x plus delta x cubed plus 2 times x plus delta x. Then I'm subtracting off all of f of x, don't forget parentheses, all over delta x. All right, x plus delta x cubed. Does anyone remember a nice quick way to FOIL that out? That would be if I was factoring it, not this one. I know. What can I use, you guys? What's a fast way to, instead of having... Which one? When I take a binomial to the third power, how could I expand this binomial?
Oh, you have to do the Pascal's triangle.
Yes, you could do Pascal's triangle. This would be 1, 3, 3, 1. So this would be x cubed, x squared delta x delta x squared, and delta x cubed. And they're all pluses. Do you remember Pascal, right? So Pascal's triangle, I mean, you could, feel free, off to the side to do x plus 3 times, or x plus delta x times x plus delta x times x plus delta x. And you have to, you know, work that whole thing out. But I don't want to do all that work, right? I don't know about you. But I'd prefer not to, and I'm just going to use Pascal. So it's a binomial to the third power, so binomial expansion, binomial theorem, 1, 3, 3, 1. All right, then this next one gives me 2x plus 2 delta x. And then I have minus x cubed minus 2x. So some of this stuff cancels, I hope. X cubes are gone. The 2x's are gone. And everything else then that's left should have a factor of delta x. And so I can cancel out those delta x's. This delta x now becomes, this was a cube, so now it'll be squared. And I just got to make sure that I get everything that's left. So what's left? 3x squared plus 3x delta x plus delta x squared.
It should be 3x squared delta x.
Maybe. No, that was the 3x squared delta x. I took rid of that delta x, so that's just 3x squared now.
Oh, you already canceled.
I canceled that delta x, yeah. And then, yeah, I canceled the delta x's. Sorry, I kind of did that all in one step. Then over here, there was still a 2 left. And again, I'm still taking the limit as delta x is approaching 0. Now I can do direct substitution. So this one just becomes 0, 0, and I have, look, it's the answer I told you up there. All right, so notation-wise, then you would write as your answer f prime of x is 3x squared plus 2. Right, that's the derivative. F prime, so start getting familiar with that notation, okay? F prime of x equals 3x squared plus 2. It's another function. What is this? This is the slope generator. That's what we just found. So we call it the derivative. You can also just call it the slope generator. It's the same thing. This will generate the slope for me at any point x. Any point x I plug in, it's going to generate that slope. So this whole idea of a derivative is that slope generator that we just found on the last page. All right, let's try two more here. One with a radical and then the last one with a rational. All right, so our function is f of x equals square root of x. So first it wants us to find f prime. When it wants you to find f prime, you're just going to do it in terms of x, keep the x's with you. Then find the slope of the graph at those 2 points. So then I would just plug in a 1 and plug in a 4. So let's find f prime first. It equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. I like to write that out every time. It helps me to memorize it and not forget anything. So what's f of x plus delta x? Well, that's just radical x plus delta x minus radical x. How am I going to simplify this guy? What?
You have to do root x plus root x plus root x.
What is that process that you're doing called?
It's rationalizing
The?
numerator.
You got it. Simon, you're on point today. Rationalize the numerator. All right, so go ahead, work it out, see what you get. I'll show my work up here. Hint on the denominator is don't FOIL or don't distribute it out when you're rationalizing. Just keep them separate on the bottom. Don't distribute that delta x. Because my hope is it's going to cancel. And if I distribute it, then I have to factor it back out again, right? Does it cancel?
Yeah.
Yeah. All right. So my last step here, I have the limit as delta x approaches 0 of 1 over x plus delta x plus square root of x. Square root of x plus delta x. Direct substitution now will let me do this. So that's 1 over 2 root x. You don't have to rationalize, you can just leave it. All right, so this equation, that's my f prime of x. That was the first step. It said to find f prime. So we just did it. There's f prime of x, 1 over 2 times root x. Then it says it wants us to find the slope of the graph. Well, this is the slope generator. So now in order to find the slope at 1, 1, I just do f prime of 1. So I plug in a 1 here, and I would have 1 over 2 times root 1, which is just 1/2. And then it wants me to also find the slope at, what was the other point? 4, 2?
Or 2.
So I just do the derivative at 4, so that's 1 over 2 root 4. So that would just be 1 over 2 times 2, 1 over 4. And I'm done. Those are my 2 slopes. Again, think of the graph for a second, you guys. It's the square root of x graph. It looks like this. I'm trying to find the slope at 1, 1 and at 4, 2. Does it make sense that the slope at 1, 1 is 1/2? Sure, that looks like it could be up 1 over 2. And does it make sense that the slope here is 1/4? Up 1 over 4, think rise over run. Makes sense, right? So you can always double check on your graph. So we figured out the derivative and then the slope at those 2 points. Kind of fun, right?
Really fun.
Super fun. You're going to get good at it. You'll practice. All right, so try this last one. Same idea here, but we have a new function, y equals 2 over t. So they give it to us y, so then they do dy dt. Again, it's just, see those d's, you think derivative. They are writing out this nice formula for us. So it wants it in respect to t. So what's f of t plus delta t? So I would do 2 over t plus delta t minus 2 over t all over delta t. We have a complex fraction. I'll let you guys try it. I use method 2. All right, is that the equation you got to at the end? Sorry. And then I would do direct substitution. So negative 2 over t times t plus 0, negative 2 over t squared. So my dy dt is just negative 2 over t squared. You could write that negative 2t to the negative 2 if you wanted to. But that would work. And they just asked us to find the derivative. Notice my notation here. Since they started with dy dt, I'm going to write my final answer with dy dt. You know, I mean, you could have written y prime or f prime. And that's it. They just wanted us to find the derivative. So that's our derivative. We didn't actually ask us to find the slope at a point. But we could. We would just plug it in for t. Did you guys get lost anywhere along the way there?
Did you say we have to set equals to like
You should write it. Again, you could just write y prime, or you could write f prime. But since they used the dy dt notation, I'm just going to stick with that notation. All right, questions?